Right, I just wanted to take a quick moment to just summarize the differences between simple molecular substances and giant covalent structures, the differences between them. Now, both of these are formed due to covalent bonds. If you don't know what covalent bonds, watch the video on that. Now, simple molecular substances are just small molecules containing a few atoms that are covalently bonded together. So chlorine atoms or ammonia atoms, NH3, or water atoms, H2O. They're just a couple of atoms bonded together, right? So these two chlorine atoms bonded together. They're just a couple of small atoms that are bonded together. And the important thing is that between these strong covalent bonds, so these are simple molecular substances, but between these strong covalent bonds of these chlorine atoms covalently bonded together, there are weak intermolecular forces in between these molecules joining them together. Now, this leads to a low melting point and boiling point because these incredibly strong covalent bonds are going to need immense amounts of energy to break, right? But for it to melt or boil, you only have to break down these weak intermolecular forces joining up these different strong covalent bonded molecules. So that's why they have a low melting and boiling point, because you don't actually have to break down these strong covalent bonds. Now, why do these guys have weak intermolecular forces? Well, it's because these different what are they, covalently bonded molecules, they're not actually between them, they're not covalently bonded together. It's just the intermolecular forces, so the forces between the atoms that connect them together. So you only need to break these weak ones to break them down. Now, meanwhile, in giant covalent structures, all the atoms are covalently bonded together. So not just a couple of them, not just 2 or 3 atoms that are bonded together and weak intermolecular forces in between, all the atoms. So, for example, if it was a giant covalent structure, which it isn't, but if it was theoretically, these would all be bonded through covalent bonds. So all the atoms are covalently bonded together in regular repeating lattices. This is very important. I'll explain this in just a second, making them much stronger and much higher and have a much higher melting and boiling point. So for example, this carbon atom, so this is a diamond. Diamond forms this sort of structure. Now, it's one carbon atom bonded to 4 other carbon atoms. And that's actually the maximum number of carbon atoms that each carbon atom can bond with. And this one structure forms another similar structure right here, right? Each carbon atom bonded to another 4 carbon atoms. And this is going to go down to form another one. So it forms regular repeating lattices, and it contains millions or even billions of these carbon atoms bonded together. So it's not just this, but it's in a much larger scale. And they form regular repeating lattices because, look, this sort of structure continues repeating and repeating and repeating, right? And all of the atoms are covalently bonded together as shown by these dashes. So they're incredibly strong. So you don't actually need to break because there are no intermolecular forces. You have to break down these strong covalent bonds, leading to a much higher melting and boiling point, and they're much stronger because these covalent bonds are incredibly strong.